Hey Geocache Talk Network fans. If you love what we do and want to support the shows, we've got two great ways to help keep the adventure going. You can join us on Patreon at patreon.com/geocachetalk for exclusive perks. Or if you prefer a one-time boost, buy us a coffee at buymeacoffee.com/geocachetalknetwork. Every bit of support helps us bring you more geocaching fun, stories, and shows. So whether it's a membership or a coffee, we appreciate you being part of making the Geocache Talk Network operate. Thanks, and happy caching.
Logwork, the creators of the fantastic logbook, made with genuine write-in-the-rain paper. The logbook's designed for the micro-containers of the present and future, geared towards the hider who'd rather go caching than doing cache maintenance. Find them at logwork.com. That's LOGWERK.com.
Calling all geocachers. At artedcrafted.com, we create unique apparel designed by geocachers for geocachers. From custom t-shirts to personalized mugs, our gear lets you express your passion. Stand out at your next event with artedcrafted.com. artedcrafted.com. Gear up for your next geocaching adventure.
Hello, everybody, and welcome to Gadget Talk. I don't know about you, Chad, and I think I told you this one, that Arted Crafted is my cloned AI voice, like put up a notch or two for radio. Could you tell?
Is that what that is?
Yeah, that's actually.
It kind of sounded like it, but you never know nowadays with AI.
Yeah, but that's me. But yeah, thank you guys for joining us tonight. We're talking about how to design 3D prints, and we got some special guests that we're going to bring in. But yeah, how's everybody doing?
Doing good.
Good.
Yeah.
Doing great. Sorry. I was reading some comments. Pulling up my Tinkercad. So.
Oh, man. Yeah. Looks like we got some people joining us today. We got Quincy Cryptid saying, "What am I doing here? I don't even have a 3D printer." And then he said, "Yet," on here. So yeah, this is
a very important key phrase.
I know. So this is a gateway experience, guys. We got Buzz8226. Howdy, y'all. Thank you for joining us, Buzz. Got DSK11 joining us from Medicine Hat. Thank you for joining us. We have, and I love this name, Mr. Geocaching. Got Mr. Geocaching joining us, who says hi, so thank you. We got David Levine joining us as well, too, that he highly recommends the bamboo printers. Got Andre Petrov, H4M, who does some amazing designs and gadget caches. We've got Nicole B. Genius joining us tonight as well, too. And she's getting ready to head to Bamarama for some awesome gadget caches. That sounds fun.
I can guarantee there'll be some there at Bamarama.
You guarantee, Mike?
I guarantee my friends at Cashcraft will be down there with some of mine for sale and to show them off.
Very cool. Could people purchase some of your designs there?
They absolutely could, including some more novelty style designs that are going to be debuting down there. Actually,
ooh, no spoilers.
No spoilers. I don't want to spoil it for the Cashcraft team there, but they should be fun.
Okay, well that sounds cool. And we got GeoFam AZ joining us too from Arizona. Man, I don't know about you guys, but I wish I was in Arizona. It would be a little bit more warm, I'm sure, than our 39 degrees that we're experiencing right now.
We're certain.
Yeah. But Chad, how's everything been your way since last month?
It's great. Busy. Just life. It's busy. Doing a lot of work, getting ready for Cache Fest coming up here in July 11th. So excited for that. And if people haven't been watching or following Cache Fest, if you're attending, the vault keys have started to hide this week. So go to follow us on Facebook, Cache Fest, and Instagram as well. And for the clues.
Very cool.
Yeah.
I just got to do a screen share on here because it looks like the Cache Fest website is up now, right?
It is.
Okay. So
we are
folks,
working on revamping the whole thing on it. So
Very cool.
Slowly.
So people just go to cachefest.com, and then it has a GC code GCBFDWB for CacheFest Savannah on July 11th.
Yes. Go on there, log your will attend if you're thinking about going. It'll help us out a lot. I think we're like 150, 160 right now.
Oh, nice. Yeah, and really logging your will attend is the best way for people to get the latest information, right? Because in that way, they get the information first. So if it's like packages, if it's like something else on here, and it looks like we got somebody pretty excited. Christ Our King 987 says, so excited for the vault keys on here.
Nice. So am I. I was excited to ship them out. Or at least some of them.
Oh man, can you tell us where they got shipped out to, Chad?
Somewhere in the U.S.
Oh, okay.
Or 48.
Oh, lower 48. Okay.
Yeah. Yep. So that's all I have so far.
Okay. Not trying to get you to spill too many beans just yet.
Nope.
Yeah.
But there'll be some hidden around this weekend, I'm sure. If you're going to a mega event somewhere. But yeah. Enough said. I talk too much.
Oh man, yeah. I was gonna say you can't spill beans. That's it's in Gary's contract still. You know, most people don't know, but I'm contractually, it's in my contract that I can't spill beans for Geocache Talk.
Ironclad non-compete.
Yeah, I just can't do it. It's just, I know. It's one of those things. There's many things in my contract, some I can discuss and some I can't. But yeah, spilling beans is one of those things I just can't do.
Interesting.
Yeah. So Chad, what are we talking about tonight?
Okay, so tonight, sorry, getting to the show here. We're going to talk about, as you see, we have great guests on here, Mike and Jason, who we're talking about designing some 3D, how to use the different CAD programs and how to do designs. Last month, we went over 3D printers, and so now we're going to go over some designs on it, from Tinkercad to 360.
Fusion 360.
Can't remember. Yeah, there you go. Fusion 360, which is what I would love to use at some point. And then Jason, you have a different one you're using?
Yeah, so I use Autodesk Inventor, which is basically
Autodesk.
Fusion 360, but like the full version of it.
The full version. Okay. So
three
you'll see the
different
differences.
tonight.
Yeah, mine's pretty basic. I do really basic modeling, super basic. It's embarrassing to show.
I love Chad.
And Mike on.
I love how you say that, and then you're just like, okay, so Chad does super basic, but super basic equals like a ton of favorite points, like all over, you know?
Yeah. Sure. Yeah. No, it does. And well, you've seen, I mean, people have seen what I design. It just takes me probably longer than the tricks that you guys have. So, and then the programs, certain programs have more to it that make things easier. So you can space stuff easier and add designs and add all kinds of stuff. So, yeah.
Oh man.
Sorry, there at the top. So yeah, if we want to start with the basic, we can, and I can go first. I was just literally looking for something that would be good to demonstrate. That's pretty simple. Something that we showed on here before, maybe. Here, we'll do a directional puzzles. So let me go on to this. And I'll share my screen. Are we ready to start with
let's go for it.
With my basic design here? I
hope it blows us away.
It's not. You guys are going to go, what? How's this guy get anything done? Why is it not sharing my screen?
As I look at the frozen in carbonite signal and space helmet signal and various other creative things behind you. Being so.
Can you see those things back there? Signal?
Yeah.
I don't turn them on because I don't even think you can see them. But yeah, and a lot of that is 3D printed. on Signal. I've actually had people ask, build him on one of the episodes, how to build him. And
cool.
I probably should at some point. I've had questions lately on doing Arduino stuff and just flashing LEDs and just some basic stuff. And so that'll be the exciting thing about next show is we'll actually probably build something. Get back into building. Okay, so this is my directional puzzle. I got to remember not to look at this screen. Nothing's going to happen. I don't know what the best way to start this is.
Well, I think, Chad, I mean, one thing I just want to say about Tinkercad, and I can't remember if I told everybody this before the show, but I was teaching a class at the university where I work, and I was thinking about like what CAD software do I start people on, and I thought Tinkercad is probably a great way to do it. Number one, I mean, you have something that's free, that's very powerful, that people can use. And I know when I was teaching the students, I mean, really, it's not intimidating either, for folks. And I kind of thought,
it's not. And there's a lot of,
yeah.
Oh, sorry.
No, go ahead.
There's a lot of fun things on it. I'm sorry, I'm terrible at talking over you. There's a lot of fun things on it, especially with Arduino, because it actually has Arduino stuff in there. And you can actually make a negative space for it if you need to fit it in somewhere. But one thing I will say before you start, if you're going to design something, you need something to measure with, something that's good. I use calipers. I think most people do. Mine are digital, and I have a 300 millimeter one, so it's big because I use.
I'm the only analog
big printers.
You're the only one with the analog calipers.
Yeah, I have some of those. I don't know where I put them. I mean, that's so 1980s. And then I always have a nice ruler somewhere too. So for everything. So I would say first thing, if you're going to do some designing, get some good calipers. Most designs are done in millimeters. At least I like using millimeters for my designs. I think most people do. And so your calipers will have all that on there. Yeah. One thing about Tinkercad, so you have your basic shapes here that you can use. So this is a solid shape, and this is a negative space shape. And then here are some other designs. If you want to add text, you can click on the text, and you can, looking at the wrong screen here. So you can add text, and you can edit it right here. So you can add that to your design really easy. And then I'll delete that. So right now up here, it shows different shapes, basic shapes, and then you can go to more advanced ones to where there's actually creatures and everything. So fun and games, electronics. If you go to electronics, there's different parts there that you can use. And then they changed this up a little bit since I've used it last. So these are the different Arduino boards or different boards to use. And then there's also a SimLab. So if you're trying to do an Arduino circuit, you can, oh, wait, this isn't it. Is that in the electronics one still? So you can add your boards and actually do, oh, you know what? That's on a different design up here.
And Tinkercad is fully web-based too, right?
Yes, it is. So you go up to circuits up here on the top, and you can design circuits and actually test the circuits that way. So I'll go back to my last thing I was working on. Actually, maybe I'll just open up a new design, and we'll just start new. So anyway. Really simple if you want to do a shape or a square box. Here's your box, and we're talking about millimeters. Here you can adjust your size. So this right now is 60 by 64, and you can adjust this however you want. And then here is your height of it. So you can adjust this however you want to make a square. You can adjust the radius on it here if you want to. The steps, the lengths, everything right here you can adjust. And if you want to add like a negative hole in it, you can. So you go to negative part. Now you can change this if you want to a solid part here. And you can change this to a negative part as well if you want to. but super simple. So like when I make certain things, I'll do a negative part to fit in it, like the directional arrows. We'll do one here real quick just to show you, and I'll try and be quick so we'll get rid of the circle. Taking up too much time. So this is 60 by 60. So I'm going to make this probably 50 by 50. And if anybody has any questions, let me know. Hopefully this is what we were hoping to explain a little bit.
Yeah.
And
as we're doing that, we got a few questions in the chat. One of them is from Chippy's Woodshop, and he said, "Do you usually dings? I think maybe design in metric."
I always design in metric.
Yeah, and I think Tinkercad actually has a setting too, where if you go into the settings, you can change it from metric to imperial as well too, if you want to.
Yeah, so if you go down to the bottom here, you can change from metric to imperial and to bricks. So it's like Lego bricks type thing. Imperial, and then you can change also in settings. So you see all these little squares here at the bottom. If I want to go over a little bit, I got to click on it. I can adjust it over a tiny bit, and it's going to go one square. You can actually change that all the way down to 0.1, and it barely moves if you're trying to move it. So you can kind of adjust it that way. So, and then on this here, this right here, these two designs right now are the same height. So if I put this inside here, and then if I group it together, it's going to show a negative space. But if I'm doing my magic blocks or the directional arrow, I actually want a backing on this, so a lower part. So let me ungroup it real quick. If you look at the arrow here on top, and you click on it, you can drag it up a little bit. So now it's going to be, oh, I hate that setting. I'm going to just go to 1 millimeter. So right now, this block here, I have it set for 5 millimeters thick. And this one here is sitting at 1 millimeter off the bottom and 2 millimeters and 3. So we're going to go 2 millimeters off the bottom. And then if I want to center all this, we can go up here to the centering area here, the alignment, and you can align it center here and here, and it'll center it. And now if we group it, it gives you a bottom piece to it. So, that's how you can actually insert like a puzzle or anything into your shape. I'm going to ungroup this real quick because I'm going to copy my negative space, because that's going to be my insert. So now I'll regroup this. And again, I'm not a professional at this. I'm going to make this solid. And now this is going to fit inside here when I print it. I actually am going to take it down a tiny bit in height or in width, just because it's going to be so tight. It's going to have a hard time fitting in, especially depending on your smash on your printer. If you have a little bit more smash than you need, it will be harder to put it on there. So I'll go 49.5 maybe. And a lot of times when I'm doing this, I'll print it and, oh, it's a little too tight still or a little too loose. So, so that'll be my space there. I'm going to make this 5 millimeters thick. And so this is going to be my block. So on the directional arrows, I think I have a pair right back here.
Hey, Chad, as you're doing that, we got the question from DS Mavis. What is Smash?
Oh, so when you're that's a good question. That's a great question. So your 3D printer, when it puts out when it's printing with your filament, the nozzle is going to push down on the bed, and instead of it being exactly round, especially for your first layer, it won't be around. It's actually going to smash a little bit to make it stick to the bed. And so if you have it smashed too much, it's going to actually have a little edge sticking out of it. Can one of you, maybe Jason or Mike, can explain that a little bit better?
Yeah, so when you're 3D printing, it's almost like you're squeezing a piping bag of icing out.
Yeah.
So when you push that down, there's always going to be a little bit of squish in that plastic goo that comes out of the printer. So that can deform the bottom a little bit and give you not a true shape. You can also think of it kind of like making allowances for tolerance. I see someone asked about a golden rule for gaps. I think that a lot of times plays into how precise your nozzle is. So if I have a 0.4 nozzle on my X1, so I usually give myself about a 0.2 millimeter leeway for what I designed versus what I'll get out of the printer. But if I had a finer nozzle, I could dial that in even more. Or if I had a crazy high-end printer, I could even almost eliminate it. So there's always a little bit of tolerances you have to play with in your models versus what you have on the digital screen versus what comes out on your printer behind you.
Yeah, and you can overcome that smash by doing a fillet on the bottom too. And then that kind of helps with your tolerancing as well.
There you go. So they've changed this Tinkercad up a little bit since I've used it last.
Yeah, I know. I was noticing like the other day when I was showing it to somebody, I was like, they've done a lot of updates recently.
I think that they updated the software I use also just got an update. I opened it the other day to practice tonight's little demonstration. I'm like, these are new menus. What did they do to me?
I haven't seen some of these. So I'm looking for the arrows, which were used to be.
Yeah, and then if you
Right at
click
the
on more
beginning.
shapes, chat, I can't remember if that's on, because I was noticing in the menu, it's like you go down at the bottom too, and I can't remember if the arrows are in there, but if you select like one of those options, I can't remember where it is, and then go down to more shapes. Do you see like the button at the bottom? Yeah, if you do that.
Oh, there we go.
Yeah,
Okay.
it's interesting because it's kind of, I thought the same thing when I was checking it out last. I was like, where'd everything go? And it's like, oh, you have to expand it with that more shapes or that more button to find more.
Oh, well, thanks, John.
Yeah, you're welcome.
So I didn't find the sample. I know I have them somewhere here close to me. But this is the one that you get 5 different arrows and they only go in a certain direction. So the arrow I have is recessed into this block. Now, again, this is only so thick, and I'm going to bring that up and make this a negative space on the arrow. Put one more. And then I'll make the arrow negative, because when I go to print it, I'll do it a different color. I think I'll change the design, the size of it to... Oops, that was the degree. So, and there's, I know there's other people who do this. It's way faster and do it differently, but this is the way that I do it. So I'm teaching you my bad habits. And then again, I'm going to center all this here. I'm going to go up here to the alignment tool, center it in the middle there and here. And then you can also center it, if you look this way, even with the top if you want to. And then if you group it, you can. But you see how that brought up the block. So when I go to print it, it's going to be in the air. So I'm going to leave it down on the bottom. But I'm going to group this. They've changed the grouping symbols too.
Oh yeah, definitely the interface. I know Chrysler King was saying, and he says he uses it for some designs as well too. He says he thinks it's so much easier and smoother than it used to be. But yeah, it definitely takes some adjustments for sure.
Yeah. Go ahead.
I was gonna say, I think one thing with modeling too, Chad, is anyone who tries this is gonna find that there's a lot of different ways to get the exact same outcome. So there really isn't there's not necessarily a right or a wrong way. There are just better or more efficient ways, but the outcomes can still be the same even if you took an entirely different road to get there.
Okay, now I'm learning here with everybody. So now if you look at, let me see if I can find that here real quick. I know I have it fairly close.
Well, he's searching. Why do you guys like designing in millimeters compared to inches?
For me, I think it's just a little more precise and it's easier to scale. If I want to go, oh, how many centimeters is that? You add a 0, and it's easier to go up and down. You're using regular numbers. You're not using fractions. I will admit I use a digital calipers, kind of like a poor man's conversion chart. So I'll measure an inch out, and then I'll hit the conversion and flip it to millimeters to get the conversion, or vice versa.
Yeah. And I think for me, Jason, it's interesting because like if I open Tinkercad, and I don't know why, I don't know if it's like a graphic design type of like feel. I'll go into the settings, I'll set the work plane to be my build plate size. And for some reason, I always think of in inches in that one. So like I just find myself like almost like out of gut, just like changing it to imperial, right away.
Yeah, I do everything in inches. I've never considered doing in millimeters.
Really? Yeah, fractions will kill me if I try and do it.
That's what it is for me too.
Yeah, but they're so ingrained in my head now that I just know them.
That's great. So this is what they look like. I don't know if we can make my screen here bigger, John.
Yeah.
So this is the design that I came up with, the arrow. So if you look at the blocks here, there's several different blocks, but they all don't fit in the same spot. Let me take down the arrow. So the arrows are in different directions, and if you see the ears on them are different. Oh, that one's gone. And if you look at the bottom, it matches. So you have to find the right arrow. So this is for a directional lock, by the way. You have to find the right direction of the arrow. So if you had like an ammo can insert, and this is a pretty cool one here to use. Seen this before, right?
Love that one.
My plan was to actually integrate these squares into one of these for a cache. Then it would give your arrows the directions you need to go for your directional lock. And you just got to find it. See, we need to add those ears on here, and then they need to be adjusted several times for the lock so they don't fit evenly. So, and I think Tricassius, I sent him one of those, and I think he has that one out somewhere.
Yeah, I almost thought I saw that in a video, Chad, that somebody posted.
Oh, no, he did the. I'm sorry. Yes, he did. I make so much stuff, and I never put it out. Kind of crazy. He did this one here. So this is a little bit different, and I can show later. I don't want to take up everybody else's time. He did the one here, the directional one, but with the lengths. So you got everything the same height.
Oh, that's right.
I got to share these on my Thingiverse or on Bamboo's thing. Now that Mike mentioned that you actually get stuff for that, I'm like, well, shoot.
Get your free fill.
I can get a new printer. It's about time.
There you go.
That would be sweet.
It's been a couple months. Anyway, I am going to add some ears to this. Let's see, how thick is this one? 5. I'm going to make this 5. And the way I'm going to do this is a little bit different. Oh, that's up in the air. There we go. I took it back down to 0 if you didn't see that. So, oops. And you don't have to use squares, you can use triangles. Why am I? Going to make a couple copies of it. So that's just Control C and V for copy and paste. I'm just going to add these around the arrows here, around this square in different places. Hopefully get them centered a little bit.
Yeah, in chat, Seaback Tribe says those arrows look very, very familiar. Like I just saw them about a month or two ago. LOL.
Yes, the other ones that I showed that Chad put out, I actually have in my Cache Odyssey Washington cache now. If you could do this here, put it around this way. Let me move that real quick, and then you can group this, and then you'll just need to adjust. You'll need to adjust every time. So, I'm going to copy and paste that real quick, and I'm going to make that. I'm going to group it, and then I'm going to make it a negative. And then that I'm going to center in here. I need to go back up to my 50 though. Oh, it's 55 because of that. Let me change this. Sorry, I need to make this the same size as that negative spot. This is why watching me, it takes me time.
Well,
So,
I mean,
okay.
I think this is great because I mean it just walks people through kind of that thought process and kind of
Yeah,
that
and a lot of it is
experimentation.
just sitting here and messing around and being like, yeah, this is a good idea, at least for me. So if I take this, put this in here, and I'm going to go up here to the alignment tool real quick, and I'll line it. And then I'm going to go ahead and, I think this is on the bottom though. Yep. So if I look down underneath, I can see it sticking through, and I think I left 2 millimeters in between. So I'm going to go up 2 millimeters and make sure my alignment is still good, which they're grayed out, so they are. And if I group it, then that's going to give me the exact space for this to sit into. And then, so that's the bottom for number 1. I should have copied it without these arrows in it, but that's easy enough to change. I can ungroup it and move this. Whoops, just grab that middle part. It's weird.
Yeah. So Chad, it sounds like I mean, from kind of what you're showing and describing people, it's looking at the positive and the negative space.
Yeah.
Looking at like combining the shapes on here too, that can be done.
Yeah. Then that's exactly what it is. And so then for my next one, I'll have the blank of this. That I'll do exactly what I just did, but instead with this, I'm going to ungroup this, or you can do other things. But if I ungroup it, what is this? Oh, there we go. That's what I'm looking for. Let me ungroup it one more time. I can take the arrow here and I can rotate it. So I can go 90 degrees if I want to. Or you just change. You don't have to do that because whenever you put your little block down, unless you're making it like I want to do on this, make it the negative space into this, so I don't have to glue this plastic on there. You can just, if you're going to glue it on, you can just turn this to whatever direction you want it to be. So if you do what I just did several times, export it as STL, then you can print it, and that works. Like that.
Chad, do you want to walk people through the exporting on this one? Because I mean, I think with Tinkercad, it's just like so friendly to do.
Sure. So, all you have to do is go up here to export and then STL, and then there it is, right there. You can click on it. Oops, I'm on my screen. It might take a minute. I got a lot of windows open, but this will open up in the Bamboo Studio, and then you can make it whatever size you want. I was just messing around with whatever size this is on here, but you can change it. And instead of having half circles on there, you can do a triangle, and you can do a square. You can do whatever you want with it, but the circles seem to work easiest for me. So you just export as STL or save to your desktop as the STL, and then open it up. I think I got like a bunch of windows open already for Bamboo. That might take a while. But that's pretty much it.
Well, very cool. Hey, Chad, we got a couple questions. So Chippy's Woodshop asks, is it possible to do parametric design in Tinkercad?
What's a parametric design?
I did a little homework. I did not know this before I did my proper homework, but parametric design is a design that is based off of set parameters. What Tinkercad is a direct design with solid geometry. So it's taking shapes and putting those shapes together in different ways and sizes to build your final design, versus a parametric one, which would be drawing something in 2D and then extruding it and modifying that object using specific measurements based on the shape itself. Like instead of just dropping a hole somewhere, you'd say, okay, 2 millimeters from the left, 2 millimeters from the top, place a hole that's 1 millimeter wide in this spot. And then if you were to change any of those parameters, it would update the model to reflect that change. So
right.
My crash
and that's
course
why I wanted to
memes this morning.
that's what I wanted Mike and Jason on, because I think their programs are they're more tuned to doing that.
Yeah, Mike can do
Tinkercad.
Yeah, and I think Tinkercad's, a great way for people to get started. And I know Chippy's Woodshop asked another question. Can you design something complex in Tinkercad from scratch?
I mean, yeah. I mean, it depends on what you mean by complex. I mean, I've designed everything in Tinkercad that I do, but I guess it depends on how complex he's talking. I think it would be easier to do in one of the other programs.
And then
that you guys have.
That's something I think we're going to see as we look at my software and what Jason uses. We'll see that the software gets more complex, but really it's just taking things that happen more frequently and making them a little easier. So I think you could absolutely do something complicated in Tinkercad. It just might take longer and take more patience from you than doing it in a more advanced software higher up the hierarchy.
Absolutely. And Chad Bell on the Move says, my daughter says Chad needs more 3D printers so that he has something to fill up his giant warehouse.
Yeah.
And I was going to say, Chad,
I have two sitting over in my pile over there. They're there in case, and I have two other ones upstairs.
So how many are you up to in your shop?
Not that many. I don't know how many I have back here. 5. 5.
Okay.
9.
Okay.
So I keep 5 behind me running. You can't see the very far end ones there. But and then I have the Prusa XL, the Bamboo H2D, and then 2 X1 carbons and a P2S. And then I have 2 Prusa MK3Ss, and then I have 2 what's that brand I hate?
Reality.
It's a big printer, big format printer. I forget, but it's a piece of junk. Don't buy it.
Okay.
I don't want to advertise for them.
Yeah,
but,
no worries.
Yeah.
Yeah, and Chippy's Woodshop put another question too, saying, Chad, can you send a model straight into a slicer from Tinkercad?
Yeah, that's what I did. So when you have to export the STL, as far as I know, in Tinkercad, and then you open it up into the slicer, which I just opened that one and then I closed it because it finally opened up. Did I close it? Oh, here it is.
Yeah, let me
move
bring
this
this back
over and share it. Oh, you still got it. Okay, so this is the design that we just went with. And in order to, while we're on here real quick, in order to make the arrow stick out, we can adjust the color we want that back to be to. But in order to make this arrow here, in order to make this arrow here white, we got to go in here, we got to highlight it and go into the paint. And then we're going to make it white. And then I'm going to just fill it.
Edge detection.
So. Oh, see, this has been updated too.
Hit the edge detection on the right below the paint bucket.
Oh, there we go. Sorry, thank you guys.
Yep.
Then I'm going to paint that arrow white. I don't know if I've ever had to click on that before. Maybe I did last time.
It caught me too.
If you do fillets or anything in your model, it doesn't have edges, so it won't detect them.
Oh, okay. So anyway, so now that's white on there. And when I go to print that, it will print that arrow white or whatever color you want to use. And so that it stands out. So, but that's how I export it. If I save it to my desktop, then I can export it into the Prusa slicer if I want, or any other slicer. I have like 4 different slicers I use. So, yeah.
Yeah. And Chad, we got another question too from GeoFamAZ. Maybe I missed seeing the end product. Once you have the negative spaces in the lid, where would the arrow pieces be when the cache is first opened?
I have them in a container that I 3D printed. It looks like this. That opens up, and so it would be sitting on top. Now, for something with an ammo can, I'm not sure where you'd end up putting them. You'd probably have to just do. You could probably just make one of these a lot smaller on there, depending on how deep it is, or you can just have them sitting on there loose if you want. But yeah, right now I just keep mine because my cache is big. It's not in an ammo can, in a box like this that has the puzzle parts on it, and it has on there the puzzle pieces. And that's how I keep them. But that's a good question. If you're putting it in an ammo can or a different container, you might just have them in a cheap plastic case like this, sitting on top. I'm not sure.
Put a magnet in it and then stick it on the top in the negative space in the top of the lid.
Yep.
Oh, that's a good idea.
Put
Put a magnet on the back. That's a great idea.
Yeah.
Yeah. There you go. That's easy enough to add the magnet to it too. So, in fact, if we want to, I can show how to add the magnet real quick. So
Yeah, and they were saying, okay, I was thinking ammo can. If I put them there loose, someone would surely lock them inside.
You want them inside, right? You want to open the ammo can. This is one of Mike's ammo can lids, right? That fits inside the ammo can. The puzzle would be on top. And so you'd want them loose inside. So you might have a puzzle to get inside, a lock, or just a lock in your description. And then they'd be, like what Jason was saying, just magnetizing to the top of the lid. And then they'd have to take them off there, which I think is a great idea. Mm-hmm. So if you share my screen there one more time.
Yep.
Just to put a magnet in there, it's super simple, and I can show you how to add magnets. I use, on this, probably a 3mm magnet. I think this would be a 3x3x3mm, but you can get all different sizes. So I use all kinds of sizes of magnets. So actually, let's change it to a 5mm magnet. Well, it doesn't matter. So you have a negative space here, and I'm just going to center it inside this block. And again, I'm going to go to my alignment tool and align it all to the center, and then group it. And then if you flip it over, you have that little negative space right there for your magnet to fit into. And I can show you how you put it in. This is how I make, it's super simple. This is how I make all my, I don't have that screen, my other camera on. All you do is you take your little 3mm magnet and you pound it into that. So that hole would be less than 3mm technically. I think I'd do, 2.9 millimeters. So it's a little bit thicker. So when you pound the magnet in, it holds it. So you just flip it over, pound the magnet in, it will stay in there, and then you have your magnet to hook it to the top or to magnetize it to the top of the ammo can.
You can go really crazy and move your magnet to the corner or something, and then put reed switches on the bottom of the ammo can lid, so the magnet hits those and will undo a latch, and then you don't have to do any lock. You just have to put the puzzle pieces together.
Pretty cool. That'd be fun. There's all kinds. That's what I like doing these shows. That's actually a really good idea to do. And you can do, if you want to make it harder, you can do a 2-piece arrow. I happen to have one right here. Sorry, I got to walk to the other end in my parts room.
It's okay, Chad. As you do that, I brought up your shop full screen so we can take a look at what's new in your shop.
I don't know if there's anything new. So this is one that I did for an escape room. And so this is big. So the parts come out, and I'll just pop them out. So that's your directional arrow. And then the arrow itself is, and I did this on a laser, is in 2 pieces. So instead of just having one, you have to figure out the directions. You actually have a whole bunch of arrows that are all mixed together that you have to figure out one by one piece by one piece, which one will go in. Now, a couple of them will fit in the same spot on one side, but the other side won't. So it makes it a little bit harder. It takes a little bit more time. But you can split it in half if you want to, the arrow, and make it a little bit harder. So that's up to you, depending on how hard you want to make it.
Yeah. Hey, Chen, just a question for you too, and I know we still got to get Mike and Jason to talk a little bit too about what they're showing. Are you using Tinkercad too to design what you're cutting and engraving with your laser cutter with the SVG file option?
I do once in a while. I will use Lightburn.
Yeah.
Which is, I don't know, it's another type of program. If you want to share my screen, you can. This is a Lightburn program, and this is for laser cutters. So you can choose your depth and your material and all that stuff. So on your layers and all this. So it's a little more complicated. You can use the Tinkercad if you want to, but I usually use Lightburn for all my laser stuff. So in every laser I have X-Tool lasers, I have my OM Tech, and I have Glowforge, and they all have their own programs that you're able to use as well. So, and they're all pretty easy. I think the X-Tool one is probably the easiest one to use.
Yeah, and I was going to say Lightburn comes with a lot of different laser engravers and cutters too. Like I know at work we even have a Rabbit laser one that's what it's using.
Yeah,
Lightburn.
Yeah. Lightburn it's not specifically for OM Tech or anything. It's like Fusion 360 and stuff. It's just a program for it. So cool. Any other questions for me?
I think that caught up with all the questions in the chat.
Okay.
Yeah.
We might run long tonight, but I'm okay with that. So which one wants to go next, Mike or Jason?
I can go, not a problem.
Okay.
So I'm going to talk about another Autodesk product. I use a program called Fusion 360, which is kind of the next step up or next progressive step up from Tinkercad. It's again, I don't know if I spiel earlier. It's called a parametric designer, which lets you constrain different aspects of the drawing to make the drawing happen, which is really hard to explain. But I want to show you in simpler terms. I'm going to make this this Geocache container on air with you in about 10 minutes. So it's like kind of a big screw top nano container. I'm going to run through building this soup to nuts real quick in Fusion 360 to show that while it looks a little intimidating, it's really not, and it's kind of intuitive once you get going towards it. Let me share my screen out here for us. There we go. So, sort of like Tinkercad, it's the same kind of large graph paper floating in a white void of space. Metric measurements down the left and the right. And with this one, instead of dragging in a shape and then working with the shape, we're actually going to draw the shape from nothing. So for our purposes, we're going to go over here and do what's called creating a sketch. We can create a sketch that's standing up to the side, to the back, to the front. We want to draw it right on the ground. So I'm going to click on the ground here, the ground plane, and start drawing. So when I click on that, you'll notice the tools across the top changed. We have some pretty simple, straightforward ones like drawing lines. We have one here that's kind of for drawing arcs and twists and turns, but we're going to keep it simple. We're going to get rid of all those, and we're going to draw a circle. I'll go over here to the circle tool. It kind of locks to the different grid points, so I'll lock it in the center, and then I can make it as big or as small as I want just by moving the mouse around. So for our purposes, we're going to make it 100 millimeters. Type that in, press enter. And now I have a big blue square floating in the void of space. So we're done with the sketch for now. So I'm going to hit finish sketch. And there we go. There's a blue circle. So what is that blue circle? That blue circle is step one of building this container. So what we're going to do is, as opposed to pulling a cylinder in, I'm going to create a cylinder from this drawing. So I'm going to go up top to where it says extrude. And that creates a little arrow on my circle. And now I can pull the circle up out of the ground or push it down into the ground and make that cylinder shape. So I'm going to make this, we'll say 75 millimeters tall. And there's our first basic shape, so from circle to cylinder in just a few steps. So this is now called a body. On the side here, you'll see we have a kind of a side menu. There's body and there's body one. And then actually, if we go here to sketches, there's the sketch I used to draw it. So that's step one. That's the base of this cache container. So what do we got to do now? Well, now we need to make a lid. So I'm going to go and draw another sketch. So instead of drawing it on the ground or on one of these invisible left or right planes, X or Y planes, I'm going to put it right on top of the cylinder. And I'm going to do what I did before. I'm going to draw a 100 millimeter circle. But this time I'm also going to draw a 90 millimeter circle. And I'm also going to draw an 80 millimeter circle. So now we kind of have this bullseye on top of our cylinder of this other sketch that's going to be more shapes we're going to pull out of this thing. So we have little measurements here to let us see how big each one is. And we're done with this sketch for now. So I'm going to hit finish sketch. So this time I'm going to, again, extrude. I'm going to use that sketch to make a new shape. So I'll go back up to that extrude tool. I'm going to click on the inner circle and the middle circle and the outer circle. And they all join together. And then again, I have my arrow back, and I can drag my arrow up into the air. So I'm going to draw it up to 50 millimeters this time. Now you'll see over here I have the option. I can join it. The option says Operation Join. What that'll do is that just makes the cylinder bigger. So it just took the 75 and added 50 more on top. I don't want to do that. So I'm going to go back. I'm going to do that again. 1, 2, 3. 50 up in the air. And I want to go over here and hit New Body. So there's some other options there I'll talk about in a second. But I'm going to go to New Body and hit OK. And now over here I have Body 1 and Body 2. I also have Sketch 1 and Sketch 2. So it's a little vague. So I'm going to go and just rename this and call this Base. And I'm going to rename this one and call it Top, because that's the top of this container, right? And then we'll do the same thing for the sketches to keep them straight. So that's the sketch I used to make the base. This is the sketch I used to make the top. So there we go. So now I have this shape here. I have a top and a bottom, not much else to it, just two cylinders sitting on top of each other, like a couple of soda cans. Now I want to do more. So one of the nice things is I can turn off these shapes if I don't want to see them. So I'm going to turn off looking at the top for now. So boop, now it's invisible. I can't see it. Then I'm going to click over to top and bring that sketch back. And I'm going to put a hole in the side of this. Because again, we're trying to make a container. So a container needs an open space to store things. And this is an example of how you can do the same thing a couple different ways. So in Fusion 360, there's actually this really cool tool up here called Shell. If I click on that, click on my shape and type 10, it hollows the entire center of that shape out in one click. Now I have a 10 millimeter thick wall all around and a 10 millimeter thick floor on the bottom, just with 2 clicks. So I'm going to actually not do it the easy way. I'm going to do it a little more complicated because I have an extra step I want to stick in there. So what I can do instead is I can go back to that sketch, go back to my handy extrude tool. It's all about pulling holes or cutting things. So now if I were to pull this down, you see it turns red and I'm actually cutting into the shape. So here I'm making a bigger shape, and then once I hit that 0 part, now I'm cutting down into it like a drill bit. So I'm going to drag that all the way down to 70. And now I've accomplished the same thing I just did with that shell command with a couple extra clicks. So same end result, different method to get there. I'm also going to take this inner circle here, and I drag this one up 20. And what I've just done is I've made this, which is, there's the bottom, there's that lip, there's the hole inside. So I've gotten far enough to make this shape right here. But the problem is I got to make this lid fit, so I've got to do the same kind of operation on the top of that lid. So I'll flip this to turn off the bottom part, turn on the top part. And I'm going to kind of do the same thing, but in reverse here. So I'm going to go again to extrude. I'm going to pull that down 30, 35, 30. And then I'm going to make space in the lid here. So I made the lip on the other one 20 tall, so I want to cut this one in 20. But as Chad pointed out, I need a little room of margin of error. So I'm not going to pull that to 20. I'm going to pull that to 20.25. Make that inside cut on the lid a little bit taller than the lip on the actual base. So there we go. I have now successfully built that much of this container. And now it gets a little complicated though. So how do I see what is going on in here? there's a cool function in here as well. If I want to inspect the inside, there's a menu here called Inspect, and I want to analyze it, and sure enough, there's something called Section Analysis. This will let me actually cross-cut this model. So I can cut it from top to bottom, left to right, front to back. It's a cylinder, so we'll do front to back because it really doesn't matter. And now I can see a cross-section of that lid. So I can actually see that seam with that itty-bitty 0.25 millimeter gap there, as well as the line where the top meets the bottom and the bottom meets the top. So that's what's going on inside that cache, kind of behind the scenes where you couldn't see what's going on. So we got this. We want to get to this. So what are the next steps? Well, I want to put threads on this. I want this to screw together so it stays shut and you can, actually keep things inside of it out in the wild. So I'm going to turn off the top again so I can get a better view of what's going on. And I'm going to go over here and create. And I want to create a thread. So create thread. There's a tool for that. Click on that. All I have to do is click where I want it. I'm going to tell it to model it, which is a step that just kind of makes it reality as opposed to mark. I'm going to say remember size, and boom, there it is. There's a thread. Cut right into the lid. No complex modeling, nothing overly difficult to make that thread happen. And I can do the same thing with the top. So I'll turn the base off, turn the top back on, and do the same exact step. And the cool thing here is over here, there are a bunch of settings. I'm not messing with them right now for the sake of this tutorial, but you can actually change these settings and make that thread the right thread pitch or the right thread size to make this thing screw into almost any common thread port. So if you wanted it to screw into an existing hole that has threading, and you know what that threading is, you could mess with these drop downs and make the thread on your 3D print thread right into another real world object with very little fuss. So I'm going to hit OK. Again, and now when we look at our little cross section, we can see there it is. Threads that are perfectly lined up without having to do any kind of complex modeling or overthinking. But we do want to add in that little bit of tolerance because, again, 3D printing, what we see on the screen isn't what we're going to get out of the printer necessarily every time. So I'm going to add a little bit of play to these. I'm going to turn off the top again. I'm going to use a tool called Press Pull, which is similar to extrude, but it has some slight differences, and it's better for this application. And click on the top, click on the bottom, click on the side, and I'm going to make it shrink by 0.15 millimeters. And I'm going to do the same thing on the top. Hit press pull, do top, top, bottom, side, minus 0.15. Now, if I turn on both of these, it says same thread, still there, still lined up, but there's a little bit more play in it. And what that's going to do, it's going to make this move a lot smoother. So you can actually spin it freely without having to wrench it on or wrench it off or worry about it being so tight that it kind of gets stuck through usage. There's enough play in this lid that it's never going to get kind of bound up by just being closed. So getting close to the end. So there's our screw top container. It's still a little square, though. It doesn't have that nice, smooth, sleek, aerodynamic Art Deco look. And that's where fillets come in. I always say it the wrong way. And that's this tool up here, fillet. So what that'll do is if I click right here, I click right here on that lip, I get a little arrow, and I can, just like everything else, I can pull that arrow in and add a nice smooth curve to the top of it. It just makes it a little bit more sleek. So we're going to move that and we're going to do a 30 millimeter curve on that. Now it's pretty much what I have here in my hand, but not quite. A few other little housekeeping details I like to do. Forgive my zooms. I like to add that same kind of curve on the inside here. Just a little one. We'll call it, that's not a little one, 7.5. And I'll do the same thing down here. We'll do a 5. And we'll do one on the outside here. We'll do a 2.5 out here. And what that's doing, it's just smoothing the edges out. So instead of having to sand it or worry about a sharp edge, or what Jason was talking about earlier, where if you add a fillet to the edge, it'll give you a nice clean and kind of compensate for some of that squish. So there you go. So now we have a screw top container. It's kind of an oversized nano container. ready to go. I could export this right now and hold it in my hand. But I'm going to do one final thing. I want to put some text on it. I actually have text on the bottom of this container. So I'm going to flip it upside down. I'm going to go back and we're going to sketch. So I'm going to click on sketch. I'm going to sketch on the bottom of this. So I'm going to click on the bottom. And then I want to center it on here. So what I'm going to do is I'm going to go to rectangle. I want to make a rectangle that starts from the center. So I pick center rectangle, click on the center. And I just kind of want to make a eyeball a box in here. I can get precise. We can do, let's see, 35 tall and 85 wide. There we go. So now I have a nice safe box that's perfectly centered on the bottom. And I can go back up to create text. I can kind of trace right over top of that box. Now I can do official geocache, www. And I want to center that, and I want to center it top to bottom, and it's obviously too big. So let's drop this down to 6 millimeters. About 6.5. There we go. Now I've written official geocache, www.geocaching.com on the bottom. And just like everything else, I can use the handy extrude tool. I can click on that text and I could make it jump out at you like a terrible 3D movie. Or I could zero it out and just make it a slight little like 1/4 millimeter engrave on the bottom. And that could be any kind of text you want. That could be that generic official geocache. It could be the GC code. It could be your name. It could be just even a blank spot where you can put a P-Touch label. But if you engrave it onto the cache like that, there's guaranteed no one's going to wash that label off, rub it off, or get rid of it by mistake if they find it in the field. So you kind of branded your cache forever with it. But that's it. That is all the steps to take to make a container like this that'll work fine outside. One thing you might have noticed is the threads point up from the bottom. So when the lid's on and it's sitting like this, water is going to go down. It's not going to make a right turn and go back up under the lid. So you get a fairly waterproof container as well. You can even go onto a hardware store and find a little O-ring you can squish in there too if you want to get it extra tight. That's it.
You probably print a TPU O-ring if you want.
Absolutely. Actually, I have right here.
We're talking about printing stuff.
There's a grouping of TPU O-rings I've printed for another container I've made for the Cachecraft crew.
That's cool. Hey, Mike, Chippy's Woodshop has a question. What's the smallest text size your printer can handle?
It depends. So I took that same container and I shrank it by 50%, and it did not handle that text very well. So it's fine right there. It did not have a good time when I shrank it down. The container still works, but the text got lost. Probably about 5 millimeters is as small as I would go on my printer before I start to lose fidelity and some of the I's and the T's don't get crossed as well.
Yeah. And Mike, could you show us too how to create an STL file in the software?
Absolutely. So let me export the base here. So I'll turn off the top. I'll go up to File, Export, and I can pick the file. So I can do an STL, or I could do a 3MF, which is something that the Bamboo printers like. Let's say we'll call this base. I'll drop this to my desktop. Export. And then I can go over into Bamboo Studio here. Import. There it is. Ready to go, ready to be printed. And it's so cool. I think we've all said this once. It's so cool to be able to draw something on the computer, hit print, and then hold it in your hand and have it physically there in the world and have it be uniquely yours or customized to be exactly what you need for your hide or your desires.
Yeah, very cool. Mike, you got a lot of good feedback in here too. DSK11 said, you guys make it look so easy. It would take me a month of Sundays to figure that out, LOL. And GeoFam AZ says, okay, that does it. I'm making time to learn Fusion. And Chippy Woodshop says Fusion can send directly into the Bamboo Slicer as well too, if you go to utilities and make it.
I've never tried that. Oh, look at that. I'll have to mess with that.
Yeah, that's a very cool tip to have.
Cool. So that's Fusion 360. I would call that kind of the middle tier. So it's maybe a step above Fusion 360, but a step below or several steps below what Jason's going to show us, which is a really cool, powerful software.
And one thing just to bring up real quick on that, since you did a Nano, I have a Nano here as well. And I just added a bunch of magnets to it to make it magnetic. And same thing, the holes are smaller than what the magnet is, and I pound them in there and they don't come out. Anyways, that's one way to make your magnetic Nano.
Absolutely.
Yeah, so I'll go next.
Right.
My program is Autodesk Inventor. So it's basically the big brother of Fusion. So this is a full CAD program that is on my laptop. It's not like Tinkercad. It's not online. So you need a computer that can kind of handle the graphics, all of that. I'll try to touch on some things that are different than Fusion, but basically everything that Mike showed you, you can do here. So it's definitely a more robust solution. I like it for assemblies a lot, which I'll kind of touch as well. But it also comes with a much steeper learning curve. It's not like Fusion where you can just drag objects and like Mike was doing to get a fillet bigger or smaller. I actually have to dimension every single part of it. So this is the main screen for a brand new part. I'll make Chad's model really quick just for fun, just so we can keep it consistent. So same exact thing that Mike was saying. You got to do a sketch, but unlike the whole grid pattern that both of them had, I just have 3 planes. So it doesn't matter which one I pick. But same exact thing where you have to sketch every single thing out. But then Fusion, I believe, Mike, you have this, you just didn't show it. You have all of these different constraint attributes that you can use. So like this one is the equal sign. So I can make these 2 sides of the square equal. So right now the color is purple. As soon as I add in a dimension, those squares, I can make this a 4-inch puzzle. I do everything in inches, so it's going to be a little different. So now those purple lines turn to black because they're fully constrained. So that one equal sign and that one dimension made a 4x4 square. So come on. So then I come here and you got to do the next part where you basically bring that 2D sketch into the 3D model. So we'll do 0.25. And you just, like Mike was doing, you start adding sketches onto the object. So one cool thing about this, I can actually project geometry from previous objects. So if I ever change that 4-inch dimension, that yellow line is going to change with it. So if I now dimension off of that yellow line, everything in that model will change for, after that. So I can do a same exact thing we did before. And start extruding this. This is the negative space Chad was talking about, but I actually have to model it in there. So now we have that square that he had earlier. It's just a little like you're making it, you're not adding the shapes like he was doing. And now to get that center section, I can project this object, and then there's a ton of modify features, different features. So I can actually come here, offset that sketch. I don't have to do anything. So this is where I can add my tolerance in right in the sketch. So for inches, I typically for 3D printing like to do 20,000, so 0.02. That seems like a good tolerance for my printer. And then can kind of print from there. So one thing in the extrusion part of this, I can go dimensions like everyone else was doing, or you can actually go to surfaces. So like this button here, I can go to a different surface, so I can actually hit that surface, and no matter how I change that surface in the future, this new extrusion will always go to that surface. I can make this a new part. Like Mike was saying, there's the tree on the side. Mine's a little more, it's a little different than his, but like I was saying, so this 4-inch circle we made in our first sketch, if I now bring this to 3 inches, all the rest of those things will automatically change and update and populate immediately. I do not have the ability to just drop in an arrow or something. So I would actually have to draw this out really quick. And you're just doing lines, rectangles, circles, same exact thing. And we can start constraining those actual objects in there to get everything to look right. So this, like, I can start dimensioning things. So that green arrow or that green dot in the center right there is actually the center point of that line. So I can put this line on that center point and then start picking some of these other constraints, like this perpendicular one, and that line will all automatically snap to 90 degrees right there. I don't need to dimension this so it's perfect, but we get the point. So we can go straight out like everyone else was saying, or we can go in. So same exact thing that everyone else was showing, but I think the kind of part that delineates this kind of software is the ability to build a full mechanical assembly, something that moves. You can, so we'll start getting into that. So I made this model a while ago. It's a mechanical little number block puzzle. So all the parts move in there. So this model itself is 6 different parts that I have modeled in here. So the tree here of all the different commands and things I did is not that big compared to some of the other models I can show after here. But every single part here builds all of these parts. I can start toggling them on and off. So this is the outer surface. We get into these inner pieces that move. And then I'll kind of get into the assembly portion. So my design, the way I typically do it is I like to design all of these pieces in one file. It makes it easy for me to change dimensions. If I change this dimension, these other parts will change instead of having multiple different files going along. But then I have to separate them out afterwards. So I have to come here and make a part or make a component here to show what is going on, or to separate it from this single part file to make an assembly. So I can come here, and now this is every single one of those parts broken out into its own file. So then I can start hiding a couple. And then, so this green part is the part that actually moves. So if I move that, you get the number 2 that comes up. So I can start playing around and in the design software and see how all of these different components interact with each other. Are my tolerances going to work? Is all of this like good enough to actually build into something? So one thing that this software allows to do, I do not know, Mike, if Fusion 360 allows you to do it, but I can inspect here, so I can actually analyze interference. So if I made a mistake, I can select 2 parts that are right next to each other, define one, define the other, and it will analyze if there's actually interferences between the 2 parts before I even get to the printer, before I try assembling them, anything. I can do this activate contact solver, which is on right now, which means these parts can, once they hit each other, they can't move any farther. So I can see how much motion I get in different parts, different things. So like this part right here, when it's fully up, are you seeing my measure screen on there? Yeah, you can you can see it's giving you a little blue dimension that's just under 0.2 inches. So that part, I can start analyzing how all of these assemblies actually work together before I even get to the printing stage, which drastically reduces my build time of an actual gadget cache. I'm able to iterate really quickly now, and then kind of see how different parts interact with each other. So this is one piece of a cache that I have. It is Shoot the Moon. So the old kids game, that was the two metal rods. You move back and forth to each other, and you have the metal ball that rolls uphill. So this cache is designed that metal ball will hit this yellow lever, and then it will push up a code. So I'm able to design all of this, see all the tolerances, see how that lever moves in relation to that number block. And this more robust CAD software kind of enables that ability to do that kind of design. Now, I use the same number block in a different cache I have. So this one, so Fusion 360 had a different way of doing it, but it's all, I can section the views as well, and I can start seeing inside of the parts. So this is all the components inside. So if I select there, then I can see how this red part moves the green part, which moves the numbers up. And it kind of gives me a very good idea before I ever get to an actual build phase of how this is actually going to work. And half the time, even then, I still make mistakes. It happens. But it kind of gives you a more robust ability to design parts that are very complicated, more complex. So, I mean, the secondhand cache episode we did in November or October, this is tractor gears out of a transmission that I took. I measured them, modeled them, and then made all of these parts off of that. This is one model that has 18 different parts that create this kind of cache. So it really enables you to build these massive models that are parts and just, I mean, this is how many steps I made to make this model. I'm up to 111 extrusions, and that's not fillets, that's not anything else. I mean, these parts can get very big. I can see how they all relate to each other all at once in the same place before I ever start making anything.
And the cool part too, Jason, is you can go back to the beginning and change a value and have that change cascade out.
Yeah, so
down the timeline.
Yeah, so you have to be very careful with how you make the parts in the beginning. So one thing I like to do, so if we go back here, there is an ability to set parameters. Hold on, let me stop sharing for a second.
Hey, Jason, as you're looking through that, we did get a few questions. Chippy's Woodshop asked, does Inverter have a free version?
I believe I don't believe so. So all 3D modeling softwares like this are basically the same. I would direct you to SolidWorks for makers. That's $48 for a license for an entire year. So it's the same exact thing. The buttons are just going to be in the different places. It's just as robust. It's just as easy. It's made for hobbyists, actually. So I have my screen back up so you can see the other window. I was only sharing one screen. So I can actually come here and set parameters. So I can add a parameter and say outside and then say 3 inches. So if I come back to this first part, I can then, oh, I'm in the wrong model. Doing the same thing over again. So I can come all the way back up to this extrusion. this first extrusion, which is the sketch, it's 2.75. If I make this now, I gotta get it exactly. That will automatically update to 3. Now, if I come back to this parameter, make that 4, that sketch will automatically update to 4. So what Mike was saying, how I can go all the way back up to the sketch and change that dimension, it really depends on how you build your model, how you build your sketches. So if I did this, I do not know how the rest of this model will react. So some part could break. It depends on how I modeled it. So it's going well so far, but it could, like if something was dimensioned, see something failed. So this extrusion here was 2 holes that were in the back for screw points. So me changing that dimension messed up something in that model, which failed. But you just have to be careful with that of changing too much stuff, especially when I get into these bigger models. So this one, I mean, I have to be careful because I'm 111 steps in. If I change the first one and I do something wrong, it will mess up 111 things. But it's just it's a more robust way to build bigger, different models than much more complex things.
Absolutely. It's super powerful, and it truly is like the bigger brother to Fusion 360 or Tinkercad. It can do so much more in depth. If Fusion 360 or Tinkercad would make the bolts, this is the software that could model those bolts into a machine or a series of gears using a tractor crankcase.
Yeah.
So can Fusion 360 also animate the part?
It can, not nearly as robustly as the Inventor software can. So I could put I have a few models and I have some very basic motion put on the mine just to see how they would work. But to my knowledge, there isn't a way to make it tell me, oh, that's colliding with this, or it's not going to work the way you think it is. It's more, this piece goes up, this piece goes down, this piece goes in, this piece goes out. Now, I could be speaking out of turn. There might be a way to do it, but it's deeper or not as robust as it is in the Inventor software.
Mm-hmm. Yeah, that's pretty impressive that you can do that. See how it works. Absolutely. You know, when you're doing the build on so if you're looking at Tinkercad, I'm printing that, and then I'm finding out, oh, it doesn't work. Now I got to change this. So you can spend so much time printing things, and then, oh, I got to remeasure this or redo this and this. And so it takes a lot longer having that animation. Yeah, that's pretty impressive. That's pretty cool.
Absolutely. And Chippy Woodshop asked a question. So far, Fusion can do all manipulations that you showed in Inventor. Can you show what Fusion can't do? Is it easier to work with mesh STL files?
I don't think the Autodesk suite of software has a bear of a time with any kind of mesh. I often have to take things into Blender and hack them up there, modifying in a mesh file versus an actual project file for Fusion or another 3D CAD software. I think it's not so much that Fusion can't do things, it's that Inventor is far more mature and can do things better and to a much greater depth than Fusion can do. I mentioned earlier, parametric is based off setting parameters, and I think Jason showed that in Inventor that's exactly what it is. It's this equals this, and this is going to match this connection, and if this changes, that changes, and it's all tied together into this string of sequence. It gets longer and longer and longer.
Yeah, I mean,
they're all tied together based on each other.
Yeah, to that exact point. So I changed those couple parameters in my first model. It's carried all the way through to this assembly file, which now I can't move because I messed something up there. So every single thing is tied together, and every single decision you make with a dimension affects every other dimension in this software. It's not like Tinkercad where you can just put the shapes together. It's much more user, like it's unfriendly for the user. It has a much bigger learning curve.
It does. And so it sounds nightmarish when you describe it, but it's when you're working in a certain part of the file, it is nice to have things tie together to be able to go back 1 or 2 steps and change it. Now, again, you're hundreds of steps deep, so changing step 1 is going to break it. But if you're on step 14, you get to step 16, you can go back to 14 and not have to worry too much about it catastrophically blowing up your project.
Oh, 100%. And I mean, I was just throwing dimensions in that model to make it blow up for this.
Yeah. And I think we got one that's probably for another show on here is a request to show us Blender on here. So I'm thinking that's probably another night, guys.
To find someone else. I am a caveman with Blender.
Yeah, I don't know anything about Blender myself.
So it's great for mesh. I always say if you want to do something engineering wise, stick with the Autodesk softwares. If you want to be creative, go to Blender. But they're different beasts completely. Again, going back to these are parametric, and Blender I think is called another direct modeler, where you start with a shape and you kind of mold it like clay and finesse it like clay to get that fine detail.
Yeah. And before I forget, I'm going to share some links that Mike shared on here for Autodesk for personal use. So, Mike, on here you were saying Autodesk Fusion for personal use is free, correct?
Yep. So just like Tinkercad, Fusion 360 is also free for personal use. It doesn't have all of the bells and whistles turned on for the personal one, but that's what I'm using when I did my demo, so it can do all the basic nuts and bolts for you. If you happen to have an educational email address at .edu, you can get access to the educational suite for Autodesk, and that includes the full flavor versions of not only Fusion 360, but Inventor and all of their software pretty much. They usually only limit you to the newer AI functionality and any kind of collaborative tool with an education license. You're also not allowed to sell anything or make any money with it because it is education.
Yeah. And Mike shared this link too for the education software distance on that one too, that compares Tinkercad, Fusion, Inventor, etc. So more from the AutoCAD line.
That's cool. I'm gonna have to download that Fusion and start working with that.
It's fine. It's nice to have that, like Jason was showing, that kind of timeline of things where you can go back or forward and kind of bounce back and forth a few steps without having to go, I screwed the whole model up, I got to start over again.
Especially if you decide like your tolerance is too tight, you change one dimension. If you model your sketches right, that one time you change it could follow through to every other part. Like you don't have to change every single part like you probably have to do, Chad, where
everything has to be changed.
That's exactly. I used to use a software called SketchUp, which is kind of a cousin to Tinkercad, and it worked the same way where you're drawing shapes, but it's like, I wanted to make that hole bigger. Well, we start over again because it's set in stone now. Where at Fusion, I can just kind of edit the sketch, and hopefully I'm not so far in the project that's going to cause a cascading failure.
Well, and adding the threads like what you did, Mike, is so much easier than I thought it was going to be.
I was so scared for so long to try it, and I did it. I'm like, oh my God, that was so easy. Like three.
I have a lot of designs I want to add threads to. So, that definitely is going to come in handy.
Yeah,
absolutely.
Super, super useful tool.
Sorry, I'm reading the comments there. So now my glasses on, so I got to get close. So anyway, that was great, guys. I really appreciate you guys coming on and doing that. We got some great comments and some good tutorials on that. And I got to step up my game as well from Tinkercad to a real software.
Yeah, I mean, Chad, you're completely slacking. Look at the shop is barren. You're not doing anything.
Yeah.
Well, and I like the way you guys did it too, because I think, Tinkercad is just such a great way to get into it, because I know when you say like CAD at first, like, hey, we're going to use CAD software, so many people are like, there's no way I could ever do that. So, I mean, using Tinkercad as a starting point, I just think is an incredible way for people to get their feet wet,
100%.
get their foot in the door, start to use it. And I think you guys just did an awesome job, like just showing all those advanced features. And I know, in here there was comments like, wow, double wow, from people. So, just so good. And I know GeoFam AZ said, great stuff, guys. You shown me that I have to up my software game. Thank you so much for sharing.
And if anybody wants it, this is up on my Maker World, Bamboo site. If anybody wants to download a plastic bubble.
And what's your name on that Maker World site?
Yep, on Maker World. And if you give me a thumbs up, I get points.
So it's 2-2-steps on Maker World, or two?
Yep. What am I? I think I'm amateur gadget. What am I on that?
Okay.
There you go. Yeah, I gave it.
Yeah, I put the link in the chat too, so if somebody goes and looks at the chat, then they can pull it up.
That's the exact one I made tonight. Well, the one, not the exact one. It's the exact same steps I took to make this one.
Nice. Jason, do you have any place that you share yours?
Not yet. Not
yet.
that advanced yet.
Stay with me. I don't share any yet. I need to start sharing them. It's not like I do anything else with them. So, yeah, I'm going to have to start sharing. So the thumbs up is how you get your points.
Yeah, people download it, like it, comment on it. There's a bunch of different ways you can earn different values of points, but every 490 points, you can cash those points in for a gift card for like filament. So like if you get $40 gift card, that's 2 rolls of filament. Not that I need more filament, but it's always nice to have. Or I could buy parts. Yeah. I could buy a new nozzle or a new AMS motor or different bits and bobs for the printer. And get feedback from people like, oh, that's so cool. So for this one, I uploaded not only the STL files, but the actual Fusion 360 file. So if you want to take that file and open it up and tweak it and mess with it, they're free to do that too.
And something I don't know if we went over when we talked about the 3D printers is the nozzle sizes. I mean, you can do so many different nozzle sizes depending on, if you're just making a sample of something, you can use a 0.8 nozzle, right? And it prints real fast. But if you want something that's really nice, you can use a 0.2, something that has really thin build lines or print lines on it. And I think we went over a little bit, but not too much on those. But also when you're looking at machines, changing nozzles out. Some machines are easier to change nozzles out than others, depending on how much you change it. How often do you guys see that you're changing your nozzles? I typically stay at a 0.4 99% of the time.
Same. I think I have a 0.2. I never bothered to put it in other than to test it once. But 0.4 does the job for the kind of stuff I print. This is a 0.4. All the gadgets and widgets I make are fine with a 0.4. The 0.2 or anything lower than that, if they even make it for the bamboo, it might be a 0.15. Those are good for like the really tiny detailed items. Or if you really want to dial in that smush, as we called it, or that tolerance, you can get the smaller nozzles. Though smaller nozzle means longer print time too, if it's a big thing.
Yeah, they have 0.2 for the bamboo.
And the machine right by your head there, Ted, that one has 2 nozzles in it, correct?
Yeah, that's the dual nozzle extruder one. So if you're looking for, if you don't need the dual nozzle, if you're not doing 2 different types of material, I would go with the H2S, I think it is. Single nozzle,
yes,
multiple filament, but it actually gives you a bigger print area. It gives you about an inch wider of a print area. So because you have 2 nozzles next to each other, right? And the one nozzle can't go all the way over to the end of that print bed. So it makes your print smaller on that. But yes, that has the 2 nozzles on it. So yeah.
Well, hopefully we made the 3D printers not scary, and we made the 3D modeling part not scary. It's super accessible. I encourage anyone to get into it if they have the time and a couple extra bucks kicking around for a printer.
Yeah. Great. And how often do you have to change your nozzles in your bamboos?
I think I've only changed the one at my X1 once, and that was when the thermistor blew out on it and I broke something trying to fix it. But I'm otherwise at like 2,000 or 3,000 hours on it, and it still prints great.
Yeah.
Good.
Nice. I don't print mine out. Again, if I have an issue with it, then I change it out. But I change the fan. I change everything out at one time.
Yeah, I have a little box in there. I use my gift certificates, and I'll buy an extra nozzle or an extra bitter bob. The nice thing is the parts are cheap. Like the printer the printer I have might be $1,000, but the nozzle's $20, and the thermistor is $8, and the silicon sock is $4. So the individual pieces are cheap. So it's not like, the main flux capacitor blew, forget it. It's all a big shot.
Yeah.
Yeah, you got to watch out for those flux capacitors breaking. That can really ruin a day. Just saying.
Exactly.
Yeah.
Great, guys. Well, I really appreciate you guys coming on. This was a great show for me to learn as well as it sounds like everybody in the chat in there doing this. So yeah, this was great. And next month we are going to have our podcast. Got my calendar in front of me. What do I do with it?
Yeah, I was going to say.
Got to write this down.
Third Tuesday is March 17th.
Yeah. Yes. So March 17th next month, we'll be on here, and I will announce it later on. But we'll probably end up doing actually a build.
That's St. Patrick's Day, guys.
Is it?
Oh yeah.
Oh. So we got to wear our green.
Got to wear your green.
Oh man, is your build going to be St. Patrick's Day themed?
Man, maybe. I mean, I have to figure something out.
Well, have you ever done a leprechaun gadget cache?
I haven't. Well, give me something to look into.
Yeah,
that will be interesting. So yeah, I'll.
You can design
rainbow
in software.
Go ahead, Jason. Sorry.
Sorry, Jay. I didn't hear you, Jason.
You can design it with your new software.
Yes.
Yeah.
Well, that's the nice thing about the Tinkercad and that being free, right? Is it got me comfortable and not nervous about designing. So when I do go into Fusion, I won't be so nervous to try and figure stuff out. But the nice thing about this too is when I have questions on any of my software that I use, I can go to YouTube and type in, Tinkercad, how do you do this? And there's so many videos that pop on to show you how to do it. I do it all the time with a lot of my designing programs and all that stuff. So don't be afraid of your software. I mean, you can figure out ways to do it, as well as on Facebook. Every software has its own page, and you can go in there and ask people how to do stuff, and everybody's super happy to help.
That's exactly how I learned Fusion. Every single click of Fusion 360 was taught to me by a guy on YouTube who did a step-by-step tutorial. He showed you how to build a Lego block and then a doorstop and then a beer bottle, and you just follow along with him and learn as you go.
That's great. Yeah. And, if you guys want to, you can send me a message at gadgettalkpodcast@gmail.com and ask me, but it'll be quicker just to go to YouTube. So perfect, guys. Well, I appreciate you guys being on, and thanks to everybody who's joining us. Went a little long, but it was worth it to me. I love the longer shows myself. It gives me something to listen to later on on my hour-and-a-half drive to work. So
always a pleasure.
Yeah, sounds good. Well, thank you guys for joining us. We really appreciate it. Thank you, everybody in the chat room, for all the great questions and all the great comments. It's been a wonderful show, and we'll see you back on March 17th. Take care, guys. Have a good night.
Good night, everybody.